Hi, I'd like to introduce the next speaker. It's Colton Myers from SaltStack, talking about how to managing your infrastructure with SaltStack. Please go.
All right. It's late in the day here. Looks like we lost a bunch of people between the last talk and this one, but oh well. You'll have more question answering time or something. My name is Colton Myers. I'm a platform engineer for SaltStack. I've worked there for a couple of years and been involved in Salt development for all that time. So really quick before we jump into the actual content, just a quick plug for my book. It was just published. This talk is going to be kind of a Learning SaltStack Lite. We're going to talk about a lot of the content that's in the book, but at a much higher level and very quickly because this is only a 30-minute talk. So let's get to it. What is SaltStack? If you're here, you probably have at least a little bit of an idea. Maybe you've come and talked to us at our booth during the conference. At its base, SaltStack is fast communication. That's what everything is built upon. In fact, when SaltStack was first started as a project, it was only intended for remote execution. On top of that, fast communication, we've been able to build a whole platform of other pieces. Remote execution is where it started, and then configuration management is probably what we're best known for. We also, you can do automation. You can manage your public or private clouds. You can do just about anything you need to, and it's all written in Python, so it's easy to extend to whatever task that you need it for. It's completely open source. This is awesome. I get paid to write open source software, which it doesn't get much better than that. The next question that usually prompts is, well, how do you guys make money? Is it just training? Is it just services? And the metaphor that we like to use is car parts. So Salt open source has all of the things that you need to build whatever you want to build with it. Everything's there. We don't hold anything back. It's all completely open source. With those pieces, we build SaltStack Enterprise, which is the finished car, the finished package. And so if you're interested in learning more about that, then head to saltstack.com/enterprise. So that's all I'm going to say about that. And with that, we're going to jump into a demo, and we're going to hope it works. Okay. This is a brand new 4-system cluster that I spun up about a half an hour ago. And I use Salt Cloud to create these machines, so Salt is already installed, and the minions are already connected to the master. I'm already throwing around terms. The master is the server from which you're controlling all of your hosts, and the minion is each server which you're controlling. So the masters control minions. So connected to this master, let's actually just run our first command here. We're going to ping all of our available minions. So as you can see, there's 4 minions. That's the minion that's local on the master, and 3 other minions, and that's almost getting cut off. Actually, I think it'll be okay. So we have 3 other minions that are separate from our master that are connected as well. The steps for installation of Salt and connecting the minion to the master are really straightforward. If you go to docs.saltstack.com, there's an installation page right there, and you can get that done. So I skipped all of that in the interest of time. So we can see that we've accepted. So the minions connect to the master, and they ask for permission to enter the SaltStack cluster. And as you can see, we've already pre-accepted these 4 minions. If we were to bring up new minions and have them connect, they'd be under unaccepted keys, and we'd have to accept them using salt key -a to accept the keys. So that's just a quick rundown of how you might get to the point where we already are. So let's talk about our first commands. So inside of SaltStack, I just realized I'm going to do something really quick here because I forgot to do it earlier. Which is just fantastic. This is what I get for demoing, huh? So what I'm doing is I'm fetching some materials that I'm going to be using later. Oops. So I just fetched some materials that I'm going to be using later and just stuck them in the correct directory on my master. So just ignore all that and pretend that I did that beforehand. Anyway, so our first command we already saw was salt test.ping. And so there are a couple of different pieces of this command that you should be aware of. Obviously, salt is the binary from which you call all of these commands. If we do salt-h, we can see a bunch of help text and all of the different options that we have available to us. And it's just a little bit too big. There we go, that's better. Okay. So, and I'm not going to talk about a lot of these options. They're pretty self-explanatory. There's some good documentation here. You can set verbose mode, log levels, timeouts, et cetera, et cetera. So in this particular command, I'm not actually using any of these, but I might have a -v for verbose or whatever. Let's bring that up to the top. All right. So after our command line options, we have this star. And this is an example of a targeting string. So we need to be able to tell Salt which minions it's actually going to be connecting to and running these commands on. And so right now I'm running star, and I need to put it in quotes because otherwise Bash will try to consume it as a glob. And this is just using globbing, actually, against the minion name. So star means everything. And we're going to talk about targeting a little bit later. Finally, we have the function which we're actually running. And this is just a remote execution module function. If you look in the source code for Salt, it's in salt/modules. And this is going to be the test module with the ping function within it. And all this does is return true. And we're going to actually look at that a little bit. If we had a function which takes arguments, we would also have arguments on the end of here. So test.echo hello, and all of our minions say hello. So let's look at the really cool thing about Salt, or one of the really cool things, is that it is self-documenting. So we have a module called sys, which allows us to see what we have available to us in our execution modules. If I do sys.list modules, and there it goes. Came back. Whew. Okay, sys.list modules. We can see the modules which are loaded on our minions, and there are a ton of them. And this list is actually not even exhaustive because the minion is only loading those modules for which it has the dependencies. So we already know we have the test module, so let's look at the functions within that module. List functions, test. And we can see, okay, we have test.arg, test.echo, test.fib, which is Fibonacci, test.sleep, tons of stuff that we can just use for testing Salt. And if we go further, we can go sys.doc and find the documentation for one of these. So test.ping. Used to make sure the minion is up and responding, not an ICMP ping. It just returns true. It's just a function in Salt in Python that returns true. Interestingly, sys can refer to itself. So this is useful to know. Sys.list functions in sys. We can see that we can also list state functions, state modules, state docs, and all these other things as well. You can get almost all of the Salt documentation right there on the command line. So this is super useful to know, especially when you're new to Salt. Let's talk about a couple of these other modules that we might have. We can install packages. pkg.install. Let's just install htop because I know it has no dependencies, so it'll be fast. Okay, so we install htop on all of our minions. The first minion actually already had it installed, so it didn't even need to install it. That's why there was nothing there. We could install Emacs, even though that's against my religion. That one will take a little bit longer. So while that runs, while that installs Emacs, let's talk a little bit about targeting. So by default, we target via globbing. So right now I'm targeting star, so we're hitting all of our minions. We can target, so as soon as this finishes coming back, you can do it. Which minion isn't coming back yet? Oh, Emacs has a lot of dependencies. That's ridiculous. Anyway, okay, so if we go back to Salt, so we can do Salt. Let's get our list of minions again here. So we can say Salt base pi star test.ping. This is just globbing. It's just using the Python globbing library. And so we can do whatever we want to. We can do star master. We can even do ranges, star minion 1 through 2. So that's just globbing. If we look in the help, oops, I got it anyway. We can see we can glob a bunch of other ways. We can glob via regular expressions. We can glob via just a comma-separated list. We can glob via grains. So grains are static information about our minions. For example, we have information such as the OS that's running on the minion, or the OS version, or the OS family, or the, let's just look. If we do salt, let's just look at one of our minions here. We have grains.items, and we can see the exhaustive list, which we're not going to go over. IPv4, IP interfaces, basically any sort of piece of static information about your minions you can think of, it's probably in grains. So we can target off of that. We can say, okay, I just want to target OS family Debian. Okay, so we use a colon to, let's bring that to the top. OS family Debian, we use a colon to delimit our key versus our value. And test.ping, and we get just our Debian minions. It could be interesting to note what these actually are. Grains.item, let's do OS, OS family, and OS release. Okay, so I have my local minion and my master are Ubuntu 14.04. I have a CentOS 6.5 minion, a Debian 7.8 minion, and another Ubuntu 14.04 minion. So that's who I'm targeting against. So that's going to make more sense. Now we have 3 Debian minions, 2 Ubuntu and a Debian. We can also use globbing in here. Debian, Debia, star, whatever. Not a very good example, but still shows that it works. And that's grains targeting. Let's talk a little bit. So we can also target with regular expressions in grains. We can also target, I'm going to skip a couple, pillar down there. We're not going to talk much about pillar in this talk, but pillar is just a secure version of grains, basically. This is information that comes from the master and is given to the minions in a secure way, so you can stick, secure data in there that only some minions are supposed to have, for example. Or you can just stick data that you want to use that comes from the master. And then finally, let's talk about compound matching. We can actually combine these matches with compound. So I can say, okay, I want a grains match, g at OS family Debian, and not g at OS Debian. Okay, so I want anything that's part of the OS family Debian, but not actually Debian. Test.ping, that should be 2 minions, and we got our 2 minions back. So that's kind of, and then the last type of targeting I want to talk about briefly is node group, which is just compound matching, but you can actually assign an alias to a compound match, because typing that out every time is going to be pretty tiresome. So in your master config, you can define groups which are assigned to these compound matches. So that covers, super briefly, our remote execution system. And it's super powerful. You can do lots of things with it. But where Salt really starts to shine for managing your servers is when you get into the state system. And so I have some states that I put in place a little bit earlier, which, oops, where am I? Okay, they're there. Okay. So this is our first state, and this is a state file that has 3 states inside of it. I've kind of pre-written them here, and at first it looks like a lot, but it starts to boil down pretty quickly into things that are simple to understand. This first line, install Apache, is just the state ID. So every unique state that we run needs to have an ID. This pkg.installed should look familiar. It follows the same model that we use for remote execution, and we basically say, okay, I want this package to be installed on my system. Okay, and then we give it any arguments, and the first argument is always name. So the name of the package we're installing is Apache 2. It's interesting to note here that the verbiage is different in Salt, or in states. When we were installing packages with remote execution, we were just saying pkg.install, because we just want to install a package, and it just calls yum install, htop, or whatever it is. Whereas in the state system, we have pkg.installed. We are defining the final state of our system, and Salt just makes that happen. So pkg.installed, if that package is already installed, it's not going to do anything. If it is not installed, it will install it, make sure it's installed properly, and return the differences that happen. Another thing to note that's interesting is this, you notice that I've just been using pkg. I haven't had to refer to apt or yum or any of these tools, even though I have a mixture of minions. And Salt actually abstracts that away for us. We don't have to worry about whether there's yum or apt on the target systems. It will actually detect that and run the correct command. The second state here is our service.running state. Again, Apache running, that's just a state ID. We can use whatever we want there, but it's useful to make it descriptive so that we know what's going on. So we want to make sure that the Apache 2 service is running. We want to also enable it so that it will run on startup. And then we have two special arguments, which we call requisites in Salt. And this allows us to create dependencies in our state tree. So for example, we require the package state install Apache. This means that the package state is always going to run first, no matter whether we've put them in what order we've put them into the file. By default, states will run in the order that they're defined, but we can massage that order as needed with these requisites. So this will make sure that the package runs first, and that it installs successfully before we try to run this state. And then this watch is a special requisite that I'm not going to talk about in too much detail, but the way it's used here means that it's actually watching this file down here that I'm going to talk about in just a minute. And if that file changes, it's going to actually restart Apache. So if you use a watch requisite with a service state like this, it will restart the service when there are changes that are made. So that's super useful. So let's talk about this final state here, install Apache conf. So file.managed, again, we don't say file.copy, we say file.managed because we just want to define the final state of the system. Okay? So we have the name, which is the target on the system, the file name on the system. We have the source, which has a special salt : // which refers to files on the master. In fact, I can just edit that file right here. If I say edit /serve/salt apache.conf, it's right there. Got a file here. And then we define the user and the group that we want that file to be set as, the mode of the file, and I actually use some templating. I use some Jinja inside of that file to get rid of some Debian incompatible stuff because I pulled the configuration from an Ubuntu machine. And finally, we make sure that Apache is installed first because same as before, we need to make sure Apache is installed so these directories are in place. So we have the state, and now we can run it. Now, you notice in the state I've actually used Apache 2 explicitly in a couple of places, and so that's actually going to fail on my CentOS machines because they expect HTTPD. So for now, I'm just going to run this on my family Debian machines, and I'll show you how to fix that in just a minute. Notice also that we don't put apache.sls, we just put Apache. So it's installing Apache, putting this file into place, making sure that the service is started. So we're already getting stuff back. So this is our Minion 2, which is my Debian Minion. And so you notice it installed Apache. It tells us all the different packages that changed. This diff is how the Apache conf file changed. And it's fairly hefty because, again, I pulled this from an Ubuntu machine. If we scroll down a little further and find one of my Ubuntu machines, we can see that there's no apache.conf is actually in the correct state because we didn't make any changes. Now, let's just do one quick test. If I add a new line to this apache.conf. That means that it'll change on the target systems, and we want to make sure that Apache restarts, because we had that watch in there to make sure Apache restarts. So if we look here, okay, so install Apache, it said, oh, Apache 2 is already installed, we're good there. But here we can see the diff of the file, because we added that new line. And then down here we can see the service restarted. So everything's working perfectly. If I run this again, now there's no changes, so everything should just be perfectly green, and nothing changed, and everything's good on all 3 systems. So let's extend this to a little bit of cross-platform agnosticism, if you will. Apache Jinja. I'm going to use Jinja to do this. So if you ignore those first 8 or 9 lines, the rest of this file is pretty much the same as before. I've used a couple of little Jinja to use these variables that I define at the top, but otherwise it's exactly the same. But if you look at here at the top, you can see that inside of Jinja we have access to our grains, which I've been using before. Interestingly enough, we also have access to our pillar, which I'm going to show in just a minute. We actually can even call out to remote execution modules from within here. So if grains is, if OS family is Debian, then we say, okay, it's Apache 2. We want to put the file there, and we want to get the file from there. If it's Red Hat, then we want to use that name instead, put the file there, and get the file from there. So I have a different file for the Red Hat machines. And down here, we just use little Jinja blocks to insert those variables into our file. So if we run this, now we can run it on all of our minions. State.sls, Apache Jinja. Our Ubuntu and Debian minions came back almost immediately again because they don't have any work to do. So they're just snappy. They just come right back. And we're still waiting on our CentOS machine. There it goes. So it installed Apache. It didn't have to install nearly as many dependencies. I pulled this file from a CentOS minion, so it didn't actually change. And if you notice here, service HTTPD has been enabled and is running. So on our Ubuntu machines, when you install Apache 2, it's automatically enabled by default. It'll start with boot up, but on our Red Hat machines, it will not. And so our state actually enabled that service for us. So, and now if we run this one more time, just to make sure, you notice they all came back almost immediately. Everything is in the correct state. And we know that every time we run this high state, that state that we've defined will be the way that we defined it. And that's that. So as my final demo, I'm going to show Pillar really quick. I'm not actually going to show how you get Pillar data onto your minions. It's fairly straightforward. It's just a series of YAML files that you get the data from, and they get sent to the minions. There's plenty of good documentation there. But I will just show you that it's already there. So let's pillar.item. I put in a pillar key called users on all my minions. It's all the same. And so on all my minions have this Larry, Mo, and Curly list of users. Okay? And so now I have another state that will actually use this data. So if we look at users pillar here, now I'm using a Jinja for loop. For user in pillar users, we have manage underscore, and we use the username because, again, this line has to be unique. So we need to use the username in our ID to make it unique. User.present, again, it's not user.add because that's iterative. It's user.present because we're defining the final state of our machine. And we give it the name of the user. Okay? So if we do this, salt star state.sls users pillar. That was fast. All right. So we can see, I could scroll through all of them, but I'm not going to. We can see here on our minion 3, we added each of these users. We can see all of the information about the user, home directory, all the different stuff that was created. Larry, Mo, and Curly are present. And if we run this again, we can see they're already there and up to date. We can define different pieces of information for these guys, their home directory or whatever, and everything will be updated as necessary. So that's the state system in Salt. And I think that's all I have. We are going to have a few questions. And again, if this is really fast. I went through a lot of content really fast. And so make sure you go back to the video if you want. Check out my book. It's really the better version of this talk because it has more information. And you can get my slides and the state files that I used at that bit.ly address. And thank you very much.
There's a microphone in the center if you want to ask questions, and I'll start with the first question. If you're using Docker, it seems like a really different style versus changing all the systems with making Docker images. Can you talk a little about the trade-offs between the two, and can SaltStack be used with Docker?
Yeah, so SaltStack can manage Docker containers, no problem. It can actually manage spinning them up and interacting with Docker. We actually just rewrote our Docker support, so it'll be in our next feature release. That rewrite will. So Docker has this alternate, there's two different forms of configuration management that are happening right now. One of them is, okay, I define the image, spin up the image. If I need to change something, I just blow it away and make a new one. And then there's the Salt, Chef, Puppet, where we are trying to just manage the systems, and we don't usually blow them away. We just make sure they get in the correct state and fix them as they need it. And I don't know which one's going to win. Honestly, we're gonna kind of see where it goes in the next couple years, because you can also use Salt to do a similar thing to Docker, where you don't even have a master. You just spin up masterless minions with Salt installed, and they pull their states from getfs, and will just run run their states on a schedule to make sure they're in the right state, and you won't ever touch those minions once they've appeared, except by maybe uploading new states to getfs or whatever, and so that's another interesting, hands-off, no master, and with those kind of things, you lose out on quick changes. You can't just do package.install and upgrade your security fix. You can't install patches with a single command. You have to actually blow them away and make new ones or whatever. So there's a lot of trade-offs, but I really like the way that we do things at Salt. I think it works really well and scales really well, and I hope that answers your question a little bit.
Are the minions aware of their state? So could you query and say what minions have this state file? So Chef can do that, right? You can query Chef and say, hey, tell me all of the ones that are running this cookbook, and it'll just spit you out a list. Is there something similar?
Yeah, so you can actually have the minions compile. So a lot of this processing actually happens on the minion. It requests files from the master, compiles them, and does its thing. You can have it compile those files down to a list of what states it's going to run and view that list. Or you can even run test runs. If you pass in fact, I can just do it really quick. If you pass in star state.sls Apache, and we do test, I didn't know you guys had changed it. Okay, if we do test equals true on the end of that, now this isn't a good example because, actually it will. There'll be, these failed because I used the wrong one. Let's do Apache_Jinja here. This will actually not make any changes on the target system. It will tell you what changes are going to be made, and so let's make a little change here. So we added a new line again. So changes would be made normally. And so if we look here, see how it's in yellow now? So now it says, okay, the file, this is set to be changed. It'll tell you exactly what's different between what you've defined and what's on the system and what's going to happen the next time you run a real state run. And this one says serve it is set to be restarted because it knows it's going to be restarted next time you run a real state run. So those are two ways that you can kind of see the state of a machine without touching it. The other one, I guess I didn't actually run the command. You can do state.show high state. Show. I haven't actually defined a top file, so I don't think this will work. But you can use show high state normally if you've defined a top file and environments and stuff that I didn't go into today. But anyway.
Can you talk briefly about the connectivity requirements between the minions and the master? Is that something that's always connected? Is it encrypted? How is it secured?
So the minions actually connect to the master. Minions don't have to have any open ports. The master just has to have an open ports of 4505 and 4506 by default. One of those is a pub port, 4505. All the minions stay connected to that all the time, and the master can pub commands out to the minions. The other one is the ret port, and when minions are done running a job, they will return their information there. That's the default setup. We have a couple of other ways you can run Salt. You can run it over SSH. It's called Salt-SSH. That's a feature-complete version of Salt that just uses SSH as the transport. And we have another experimental transport that's actually over UDP. It's called rate, RAET, Reliable Asynchronous Event Transport. And it's really promising. The drawback there is that you have to have open ports on the Minion. So, but yes, that connection is always open, but it's very lightweight. And yeah, I hope that answers your question.
Hi, could you talk a bit about Reactor and maybe overstate?
Yeah, so Salt has an event system built into it. Minions can fire events. In fact, you can actually put events on the bus from third-party applications even. And then the master sees those events and can react to them by running commands, running states, etc. That's the really high level. It's really cool because you can make self-healing infrastructures and reactive infrastructures. And then overstate is actually deprecated in favor of orchestrate. So orchestrate allows you to run states and commands on Minions in kind of batches. So if you need to bring up your database servers before you bring up your web servers, if you just run normal states on them, they'll all just run their stuff without knowing about each other at all. Whereas orchestrate allows you to make dependencies across clusters of servers. I want to make sure these servers ran these states successfully before I even start running these other states over here. So that's state.orchestrate, and there's information about that on the docs. So.
It looks like the last question. So thank you.
Yeah, I think we're good. Thanks, everybody.